Did you know that major depressive disorder, also known as MDD, is among one of the most common mental disorders in the United States? And according to an article published in March 3rd, 2007 by the U.S. National Library of Medicine, 1 in 6 men and 1 in 4 women would be affected by MDD in their lifetimes. And today, I will be revealing what major depressive disorder is and how it could physically alter our brain that explains the symptoms experienced by the victims of depression. I hope to present this by first defining what it means to be clinically diagnosed as depressed and its commonality in U.S. adults. Then I will speak briefly about the functions of the hippocampus, the amygdala, and prefrontal cortex that make up our limbic system and how they are affected by depression. And lastly, I will explain how these affected areas change the structure of our brain. I chose to speak about this because I have personally struggled with depression throughout my entire life. With minor or major episodes, it's always been present. I never understood why I couldn't just feel normal. And it wasn't up until I was old enough to do my own research and search for professional help is when I came to realize the inner workings and biology of depression, which gave me a sense of closure that I wasn't all in my head. And since depression shows its highest prevalence in young adults, such as myself, 18 through 25, the information I'm about to provide will be crucial in understanding the effects of depression has on our brain, which could aid in minimizing the damages caused on our academic, personal, or professional relationships. Now let's begin by revealing the definition of major depressive disorder and how common MDD is among U.S. adults. Major depressive disorder is defined and diagnosed by a period of at least 2 weeks when a person experienced a depressed mood or a loss of interest or pleasures in daily activities and had the majority of the symptoms such as problems with sleep, eating, energy loss, concentration, or even self-worth. And a survey conducted in 2017 showed that an estimate of 17.3 million adults in the U.S. had at least one major depressive episode, and about 63.3% of those adults had 1 or 2 major severe impairments to their daily livelihoods. This was a study released by the American Psychiatric Association. At least 50% of those who recover from their first episode of depression would more than likely have recurrent episodes. This data illustrates how common MDD is in our country and the probability of recurrent episodes in people who have recovered from depression. And now that we have a basic understanding of what MDD and how common it is, let's proceed in explaining how depression affects our brain's internal structure and their functions. Depression damages our limbic system, which involves the hippocampus, amygdala, and prefrontal cortex. These structures deal with emotion, memory, and regulating hormone production. And it all starts with the hippocampus, which is located in the center of the brain, responsible for long-term storing memories and the production of hormone cortisol. The body produces cortisol during times of physical or mental stress, like being depressed. High levels of exposure could damage our dentate gyrus, located in the hippocampus, that is responsible for the production of neurons. This slowing of production of neurons could cause memory problems. And since hippocampus is producing excess amount of cortisol due to depression, it also causes the amygdala to become hyperactive and enlarge. The amygdala is responsible for our emotions such as fear and pleasure, and due to the damages inflicted by it, can cause some disturbances in our sleep and activity patterns just as found in victims of depression. And the last part of our brain that is affected by it would be our prefrontal cortex, which is responsible for our self-drive and in order to set and achieve goals. The secretion of cortisol caused by depression causes this cortex to shrink, which then leads to energy loss and motivation found in depressed patients. This shows that cortisol plays a major role in changing our brain structure, and brings me to my last point on how these affected areas start to shape our brain structure. When prolonged exposure in cortisol is presented, studies have shown that the brain structures could shrink, such as the hippocampus, as well as the recurring episodes of depression could lead to the inflammation of the brain and decrease the function of neurotransmitters. All these structural and cognitive changes of our brain experienced during depression, and by understanding how depression can take control of your brain's ability to regulate hormones, emotions, and memory, could aid some individuals that find closure sat just as I did and encouraged them to find professional help just as you would for the common flu.